Solving equations in quadratic form. 1. Make a substitution. Let u equal the variable expression whose square is present in the equation. 2. Solve the resulting equation for u. 3. Using the original substitution, back substitute to x and then solve for x. Step 4. Check your answers. In this first case, notice it almost looks quadratic, but not quite there. It has 3 terms. The third term is a constant, and the first exponent is exactly double the second exponent. That leads us to believe that it's almost quadratic. To make our substitution, we're going to let u be this middle piece. So let u equal x to the negative 1. Now we rewrite the original equation. 2 times x to the negative 1 squared minus 7 times x to the negative 1 minus 4 equals 0. Now we just need to go in and replace those parentheses with u. Notice x to the negative 1 we're calling u now. So we get 2u squared minus 7u minus 4 equals 0. Now we have a quadratic in terms of u. We'll solve this using the AC method. A times c is negative 8. Two numbers whose product is negative 8 and whose sum is negative 7 are negative 8 and 1. So rewrite that quadratic as 2u squared minus 8u plus u minus 4 equals 0. Now we'll solve by grouping. The first 2 terms have a GCF of 2u. When we factor out 2u, we get u minus 4. The second 2 terms have a GCF of 1. When we factor out the 1, we get u minus 4 equals 0. Notice the parentheses are the same, so we'll factor out those parentheses. U minus 4 times 2u plus 1 equals 0. So we'll set each factor equal to 0 and solve each of these. U is equal to 4 and u is equal to negative 1/2. Now be careful, you don't want to stop here because we haven't found x yet. We found u. So we need to go in and back substitute. Substitute what we said u is. In this case, u is x to the negative 1. And now we need to solve for x. X to the negative 1 is the same thing as 1 over x equals 4. So we'll just rewrite those x's as 1 over x. And now solve. For x equals 1, x is equal to 1/4. Then on the other equation, cross multiply it and we get x equals to negative 2. Now it's always a good idea to go back and check these just to make sure that you don't have extraneous solutions. In this case, they do both work. In the next example, we're going to set this middle piece equal to u. So u is x to the 1/4. When we rewrite our equation, we have x to the 1/4 squared minus 3 times x to the 1/4 plus 2 equals 0. Now we can go in and make our substitution. Replace those parentheses with u. U squared minus 3u plus 2 equals 0. Factor. We're looking for two numbers whose product is 2 and whose sum is negative 3. That'll be -2 and -1. Set each factor equal to 0. And we get u equals 2 and u equals 1. Keep in mind, we don't want u, we want x. So we need to go in and back substitute what our u is. So instead of writing u equals 2, we'll replace that with x to the 1/4 equals 2. And instead of u equals 1, that is x to the 1/4 equals 1. Now to isolate the x, we will raise both sides to the 4th power. And we get x to the 2 to the 4th power is 16. And then on the right equation, again, we'll raise both sides to the 4th power. And we get x equals 1. In the next example, let u be x to the 1/3. Rewrite our equation. Replace those x to the 1/3 with u's. 2u squared minus 5u minus 3 equals 0. Here we'll use the AC method. AC is -6. Two numbers whose product is -6 and sum is -5 will be -6 and 1. So rewriting that quadratic, we get 2u squared minus 6u plus u minus 3 equals 0. Factor by grouping. 2u is our first GCF. We're left with u minus 3. Our next GCF is 1. We're left with u minus 3 equals 0. Factor out the parentheses. And set each factor equal to 0. U minus 3 equals 0. 2u plus 1 equals 0. So we have u equals 3 and u is equal to -1/2. Keep in mind, we don't want u, we want x. So we're going to go back and resubstitute that. So we have x to the 1/3 equals 3 and x to the 1/3 equals -1/2. Cube both sides to get x by itself. And we get x equals 27. The right equation, again, we'll cube both sides. And we get x equals -1/8. Keep in mind, it's a good idea to check your answers. Absolute value equations. 1. Isolate the expression containing absolute value bars. 2. Be sure that there is a positive constant on the other side. 3. Write 2 equations and solve each individually. The inside expression equals a positive constant and the inside expression equals a negative constant. Step 4, check your answers. But these will not generate extraneous solutions. It's just a good idea to check. In our first example, notice the absolute value has already been isolated. So we're simply going to do x equals -10 and x equals +10, and we are done. In the next example, we first need to isolate the absolute value. So first we need to subtract 1. Absolute value of 3x minus 1 is equal to 2. Once you've isolated the absolute value, then you can drop the bars and create 2 equations. We're going to copy the inside of the bars And on the right side, we're just going to do a -2 and a +2. You just do the negative and the positive version of whatever constant is on the right side. From here, we need to add 1 to both sides. 3x equals -1. Divide, and x is equal to -1/3. On the right equation, again, we'll add 1 to both sides and divide. X is equal to 1. It's a good idea to check these, but we don't have to. Absolute value equations will not generate extraneous solutions. In our next example, again, we need to first isolate the absolute value bars. So subtract 4 on both sides. And then divide by 2. Dividing by 2 leaves us with the absolute value of x squared plus 1 equals -2. Now there's a problem with this, because no matter what happens on the inside, the absolute value will make this a positive number. And we can't have a positive number equal to a -2. That's not possible. So this equation has no solution. And again, the way we write that is 0 with a line through it, or you may see it written as the empty set. Those both mean no solution. Polynomials with degree higher than 2. 1. Set the equation equal to 0 and factor the polynomial. 2. Set each factor equal to 0 and solve each for x. 3. Notice you'll have the same number of solutions as the degree of the polynomial. Step 4 is to check your answer, but these will not generate extraneous solutions. It's just a good idea to check. For example, let's set it equal to 0. X cubed plus 4x squared, subtract the x and subtract the 4, and now the right side is set equal to 0. You have a 4-term polynomial, so we'll use factor by grouping. The first 2 terms have a GCF of x squared. When we factor that out, we're left with x plus 4. The last 2 terms have a GCF of -1. When you factor out a -1, we're left with x plus 4 equals 0. Notice the 2 parentheses are the same, so we'll factor them out as x plus 4, leaving you with x squared minus 1 equals 0. Now we set each factor equal to 0. X plus 4 equals 0. X squared minus 1 equals 0. The left equation, we simply subtract 4, and x is equal to -4. On the right, x squared equals 1. Add 1 to both sides, and now take the square root of both sides, and x is equal to plus or minus 1. Remember, when you take the square root of both sides, you need to add on that plus or minus. Notice we have 3 answers: -4, plus and minus 1. The degree is 3. That indicates that we should have 3 solutions.